Dear students, today onwards we will be starting the fifth module. And the first topic in the fifth module is the circle diagram and the testing. Before the circle diagram, we will have to understand the testing that are to be done on three-phase induction motor in order to understand different parameters of the machine as well as to estimate the efficiency and to get the parameters that are required to draw the circle diagram. The first test that is done on induction machine is to measure the stator resistance. We can apply a DC voltage and measure the voltage applied and the current that is passing through, and by V by I method we can measure the resistance of one of the windings. And we will be getting the DC resistance that is given as RDC equal to V by I. And we can multiply a factor 1.25 in order to get AC resistance. If you take multiple readings, you can go for the average of resistances and you can calculate the AC resistance. The second test is block rotor test. It is similar to the short circuit test that we do on a transformer. The rotor of the machine is kept at standstill, N is equal to 0 and the slip equal to 1. We can hold the rotor in order to prevent from rotating. And the rotor circuit is short circuited. If it is the case of a slip ring induction motor, we will have to short circuit through slip rings. By using the three-phase auto transformer, we can adjust the voltage applied in order to get the current through the machine as the rated current, that is given by IS, the reading from the ammeter. We can take the readings of ammeter, voltmeter and the wattmeters. The input that is given to the machine will be the sum of the stator copper loss and the rotor copper loss. The iron loss will be negligible because the applied voltage on block rotor test will be very small, and the mechanical losses will be 0 because the machine is prevented from rotating. The slide shows the tabular column that is required to take the readings of the block rotor test. As I had already mentioned, the block rotor test is similar to the short circuit test that we conduct on the transformer. From the test we will be getting the full load copper loss because we allow to flow the rated current through the machine. And from the same we can calculate what will be the total resistance of the stator and the rotor. From the full load copper loss we can measure the resistance that is referred to the stator side. We have the equation, the input power PS is equal to W1 plus W2, the sum of the wattmeter readings, and we have the equation PS is equal to 3 IS square R01 because the entire input is the total copper loss, and from the equation we can find R01. We can also write PS is equal to root 3 Vs Is cos phi s. From the same we can calculate cos phi s. Z01 equal to Vs divided by root 3 divided by Is, that is the total impedance referred to the stator. X01 can be calculated from the impedance and resistance referred to the stator side, that is X01 is equal to root of Z01 square minus R01 square. x1 equal to x2 dash equal to x01 divided by 2, and r2 dash is equal to r01 minus r1. R1 can be obtained from the previous test, that is resistance measurement. From the block rotor test we can also find out what will be the normal short circuit current for the rated voltage, that is ISC, that is required for drawing the circle diagram. The third test that we need to conduct on an induction machine is no load test. It is similar to the open circuit test that we conduct on the transformer. Here we apply the rated voltage, that is V0, and we will be measuring the ammeter, voltmeter and wattmeter readings. Whatever be the input that is given to the machine, that is the sum of W1 and W2 will be the sum of the stator copper loss, the mechanical loss and the iron loss of the stator alone, because at that condition, since the machine is running at the rated speed or at N, the slip is very small, or we can consider slip equal to 0. When the slip is equal to 0 or when it is very small, the frequency of the rotor circuit current will be very small, and by which we can understand the iron loss on the rotor side will be negligible, and the rotor resistance will be very high, that will be equivalent to the open circuit condition. From the test, it is also possible to separate the windage and frictional loss. That is, we can conduct the test for different voltages and we can plot a graph between the applied voltage and the input power for the same conditions of the test. And we can extrapolate the graph and we will get an intersecting point on the y-axis at B. The point B will be for an applied voltage equal to 0 condition, or the applied voltage equal to 0. At that condition, the iron losses will be 0 and the resistance drop or the corresponding loss for the stator also will be equal to 0. So the portion that is shown on the graph, that is OB, will be equivalent to the windage and frictional loss. In the slide we can also see the tabular column that is used for the no load test. As I had already mentioned, the no load test is same as that of open circuit test that we conduct on the transformer. We get the no load power input, and we can also calculate the no load power factor, no load current, and the elements that are corresponding to the shunt branch or the exciting branch of the equivalent circuit of the machine can be obtained from the no load test. We have the equation Pi is equal to root 3 V0 I0 cos phi 0. We have the equation IW is equal to I0 cos phi 0, that is the working component or the loss component of the current. Im is equal to root of I0 square minus IW square. Z0 is equal to V0 divided by root 3 divided by I0. R0 is equal to V0 divided by root 3 divided by IW. And X0 is equal to root of Z0 square minus R0 square. In the last module we had already discussed the equivalent circuit of a three-phase induction motor. Here in the diagram we can see the approximate equivalent circuit of induction motor. The different power stages are also marked in the diagram. Pi is the total power input, and the shunt branch we have R0 and X0, and the corresponding currents IW and IM, the working component and the magnetizing component of I0, the no-load current. Corresponding to R0, we have the iron losses as well as the mechanical losses, which we can obtain from the no-load test on the machine. Corresponding to R1, that is the stator resistance, we have WCU1, that is the copper loss on the stator. PIR is the air gap power. WCU2 is the rotor resistance loss, and P0 will be the output that is available from the machine, the actual output. We have the equation PI is equal to P0 WCU1 plus WCU2 plus WI plus WL, or we have the output power equal to the input power minus the total copper loss on the stator and the rotor minus the iron loss minus the mechanical loss. WCUT is equal to the sum of the copper loss on the stator and the rotor. Hope you have understood how to measure the resistance of the induction motor winding, how to conduct the no-load test and block rotor test, and which all are the parameters that we can obtain from all these, and how to draw the approximate equivalent circuit, and how to get the parameters of the same from these tests. Thank you.